and you're watching Space Girl. So finally we now know that there was this theory which described relative motions, which we call Galilean relativity. However, ultimately this theory failed due to its incompatibility with the laws of electromagnetism and most importantly with the fact that speed of light is a constant. We also discussed how Michelson and Morley experiment helped us discover this fact and how we came to know that we need a new theory of relativity. Now during all this, Einstein came along with his special theory of relativity. He considered two postulates in order to describe the relative motion. Number 1. Laws of physics remain the same in all inertial frames of reference. And number 2. Speed of light c is a constant irrespective of frame of reference. Well, the first postulate is pretty much the same as Galilean principle of relativity. However, the second postulate changed the concept entirely. Well, on hearing that the speed of light is a constant, it doesn't seem to be a very big deal, right? However, it has a rather deeper meaning. And also because of this, the second postulate is very difficult to accept because it seems to go against our everyday common sense. So to make this point clear, let us consider an example. Suppose that you are standing on a car and the car is moving with a speed 50% the speed of light, that is 0.5 c. Also, you are holding a ball in your hand. Now you have a friend observing you both, you and the ball, from the ground frame of reference. Now if you throw the ball with a certain speed, according to Galilean relativity, the speed of the ball as observed by the ground frame of reference, that is by your friend, would be speed of ball added to speed of your car. Well, of course, this is very intuitive and it goes very well with our common sense. But now let's consider another example. Let's replace the ball with a light source, such as a torch. So now this time when the car starts to move with speed 0.5 c, and when you turn on the torch, the light flash moves ahead with the speed c, the speed of light. But then what would be the speed of this light flash according to the ground frame observer, your friend? Of course, it would be the speed of light added to the speed of the car. So it becomes 0.5 c plus c, which is 1.5 c, 1.5 times the speed of light. But wait, this is not possible because laws of electromagnetism tell us that the speed of light remains a constant no matter what the frame of reference is. Which means that even for the ground frame observer, the speed of light will be c. Okay, I can understand this seems very counterintuitive because this is not what we generally observe in our everyday life. Well, that's because the objects around us are not really traveling at such high speeds so that we can observe the relativistic effects. Now, after all this, two things were clear. Light does not require any medium to travel, and there is no such thing like ether. Space is vacuum. Second, light is an electromagnetic wave which travels at the speed 300,000 km per second. Now, constancy of speed of light led to some consequences. Einstein's postulates required some new considerations of the fundamental nature of space and time itself. The postulates affected the measurement of time and space intervals for different observers in different frames of reference. Okay, in order to understand what I said just now, recall the first video in which we discussed Galilean relativity. We saw that the speed of any object is a variant quantity. It changes with change in frame of reference, which means that for different observers, speed of the same object will be different. On the other hand, we saw that length and time were constant quantities. They were invariant. They do not change for different frames. Length of any stick remains the same for every observer in every frame of reference. Same applies to time. But in the case of light, on the contrary, speed happens to be a constant quantity. It does not change with change in frame of reference. And since speed, length and time are all related, in order to maintain the constancy of speed of light, length and time must vary to compensate. This clearly means that length and time are no more absolute. They also can change with change in frame of reference. Length of a stick may not be the same for you and for me. Time shown on the clock of yours and of mine can be different. Well, all this happens just because speed of light is a constant. Well, I can understand this sounds really weird and hard to believe, but trust me, this is true. So in this video, we saw what are the postulates of special relativity and how they entirely changed our understanding of speed measurements. In the next video, we will be looking at the consequences of constancy of speed of light, length contraction and time dilation. So until then, keep stargazing.